You know that awkward pause, right? When you're talking to an AI, you ask a question and there's just silence? That little bit of lag completely breaks the flow of conversation. Well, we're going to dig into a new AI architecture called Nemotron Speech, and it's designed to get rid of that lag for good, letting machines listen and understand, well, just like we do, in real time. So for what feels like forever, voice AI has been stuck with this really frustrating trade-off. You could have a system that's super fast, responding instantly, but it probably wouldn't get the nuances of what you're saying. Or you could have one that's really smart, that gets the context, but you have to wait for it. It's always been this choice between speed and smarts. All right, so to really get why this new approach is such a big deal, we first have to understand the root of the problem. And it all boils down to something called the streaming dilemma. Basically, the old, clunky way that systems have tried to listen to a conversation as it's happening. So here's the classic bind I was talking about. On the one hand, you've got models that chop up audio into these tiny little pieces. And yeah, they're lightning fast. But because they only see a tiny slice of the conversation at a time, they often miss the bigger picture, the actual meaning. Then, on the other hand, you have models that wait and wait for a whole sentence to finish. They're way more accurate, for sure. But that delay, that's what creates that awkward, unnatural lag. You just couldn't win. Now, the common workaround for this has been something called a buffered approach. The idea is to process chunks of audio that overlap a little bit. But look at what's actually happening here. With every new chunk, the system is reprocessing audio it's already heard. It's doing the same work over and over and over again. This isn't just inefficient, it's a huge waste of time and computing power. And that exact inefficiency, that constant rework, is where Nemotron Speech comes in with a totally different idea. This isn't just a small tweak on the old way of doing things, it's a genuine breakthrough in how we think about processing streaming audio. The secret sauce here is what's called cache-aware streaming. Think of it like this. Instead of constantly rereading what it just heard, the model keeps a short-term memory, a cache, of the conversation so far. So it only has to process the brand new audio that comes in, while using its memory to keep everything in context. No more redoing work. And this analogy just hits the nail on the head. The old models, they have to go back and reread the entire chapter every time a new word is spoken. It's exhausting. But this new cache-aware model, it's much smarter. It just glances at its notes about what was said before, processes the new stuff, and then jots down a new note. The jump in efficiency is just massive. Okay, so how does it actually pull this off? Well, this isn't some simple software patch. This whole idea of efficiency is baked right into the DNA of the model, right from the very beginning. Let's peek under the hood. So the engine here is a special kind of encoder called a cache-aware fast conformer. It has 24 layers, and its whole job is to do that smart caching we talked about. That's paired with what's called an RNNT decoder, which is what actually turns the sound into text. The whole thing is built with 600 million parameters, so it's a pretty hefty model. And a really cool feature is that it handles things like punctuation and capital letters all on its own, so the text it spits out is clean and ready to use. And this part is absolutely key to why it works so well. You know the saying, practice how you play? Well, that's exactly what's happening here. See, most AI models get trained in a perfect world, where they can hear the entire audio file at once. But then, in real life, they're thrown into a live conversation with only bits and pieces of audio, and their accuracy just tanks. This model is different. It's trained under the exact same streaming conditions it'll face live. So there's no surprise, no drop in performance. What it learns is what it does. Okay, so all of this clever design leads to a really, really cool payoff. You get to decide what's more important for your specific need, speed or accuracy. And you can change it on the fly with the same exact model. Check this out. The same model gives you 4 different performance modes. You can turn the dial all the way to fastest and get a response in just 80 milliseconds. Perfect for something like a super responsive virtual assistant. Or if accuracy is everything, say for live transcription, you can turn the dial the other way, give it a bit more time to think, about 1.1 seconds, and get much higher quality results. And you can see the results right here in the numbers. We're looking at word error rate, where lower is always better. At that super fast 80 millisecond setting, the error rate is about 8.5%. Not bad at all. But just by changing a setting on that same model to give it more context, you slash that error rate down to just over 7%. That's a huge jump in accuracy, all without needing to switch to a different, bigger model. That kind of flexibility is a real game changer. Now, of course, while this is a massive leap forward, it's not the end of the road. There are still some things to be aware of and areas where this technology can grow. So first off, right now, it's English only. Also, for really massive, large-scale uses, that memory cache we talked about could potentially become a bottleneck if it has to remember a ton of context for thousands of users at once. There are also some super subtle inconsistencies in context that can pop up. These aren't deal breakers by any means, but they're definitely the next challenges to tackle. So when you boil it all down, the big takeaway is this. By making an AI model practice how it plays, by training it to work just like it will in the real world, we can finally break free from that old choice between being fast and being accurate. This shows we don't have to sacrifice one for the other. We can actually, finally, have both. This really is more than just another speech recognition model. It represents a fundamental shift in how we design AI for real-time interaction. By finally solving that core dilemma between speed and context, this cache-aware approach provides a blueprint for a future where our conversations with AI are truly seamless, responsive, and, actually feel natural.